All right. Anyway, appreciate the opportunity to present to everyone today and to be able to share some insights into our water innovation program and how Alberta Innovates Energy Environment Solutions is addressing some of Alberta's water challenges and opportunities. So I learned a lot this morning, already today, but there was one thing about water that I didn't realize, and I will admit I'm a bit of a Bob Dylan aficionado, in that I probably have 12 or 15 DVDs, including 10 LP sets and 5 LP sets, but I didn't realize that 3 of the 6 lines that were sung in the part that you shared, Eddie, with us with the times they were changing had 3 metaphors related to water were in that song. So even Bob Dylan was recognizing the importance of water. So what I want to do is share a little bit about Alberta, the sort of policy foundation for water management in Alberta, and the strategies that we have to support innovation. And since 2003 in Alberta, we've had a very strong foundation for water management through the development and implementation of the Water for Life strategy, which has 3 important goals that are important to anyone: safe, secure drinking water, healthy aquatic ecosystems, and sustainable water supplies, or water supplies for a sustainable economy. So the innovation system that we've built on this, which include 2 different water innovation strategies, including the most recently updated Alberta Water Research Innovation Strategy in 2014, and the very specific performance goals that we put into our business plan try to address support for the Water for Life strategy by being able to provide for safe, secure, and reliable water resources for 6 million people by 2030, to enhance the health of aquatic ecosystems from the 2010 baseline by 2030, and to improve the overall efficiency and productivity of water use by 30%. So our research portfolio is built around supporting these 3 targets. Our commitment to water research can be summarized certainly in 2 easy metrics and 2 easy graphs. An example being over $40 million of investment into water research and innovation in the province, and over 72 projects have been supported to date. They sort of span 5 different main disciplines, being healthy aquatic ecosystems, watershed management, groundwater management, and then aspects of both industrial, rural, and urban water use and reuse. So I want to touch on just 3 projects as examples that provide a bit of insight into this portfolio that address both sort of present challenges, emerging challenges, say for the next 20 to 30 years, and then what we see as long-term water management issues in the province. And so these 3 projects, if we start, I'm going to present just a real quick update for one of the projects being led by Dr. Bernard Mayer from the University of Calgary in the Geoscience Department, that's specifically looking at baseline isotope geochemistry in Alberta's groundwater. And the purpose of this is to see whether we can develop a system to test the impacts of tight oil, tight gas development on groundwater resources in the province. So this is certainly a challenge. There's uncertainty and concern in the population whether there's a connection between the impacts of hydraulic fracturing on our freshwater resources and our ability to get fresh groundwater. And so the approach that Dr. Mayer is taking in his lab is to look at whether there are fingerprints in the water, fingerprints in the gases, or fingerprints in terms of the constituents that are found in this water-gas matrix that allow you to differentiate between resources that are coming from deep below ground and whether there's connections with the important shallow aquifers where we get our freshwater supplies. And so what they found today is a number of things. I'm going to summarize the research program that we've been involved with in the last 3 years in 3 main points. Number 1, looking at concentration of methane in shallow aquifers itself is not a good indicator of whether there's a connection between deep and shallow methane sources. It's highly variable. It's dependent on pumping rates. It's dependent on depth to groundwater. So concentration of methane in groundwater itself is not a good indicator of whether you've got connections to fracking operations. However, if you look at stable isotope ratios, things like the ratio of C13 to C12, the ratio of deuterium to regular hydrogen, that these fingerprints are relatively stable. So comparing stable isotope ratios as well as an indicator of dryness, looking at both methane concentrations in relation to ethane, propane, butane, and pentanes actually provide really good tracers. And so the take-home message from this work is that they developed a very good tracer system that allows for making connections to test the impacts, whether unconventional gas development is having potentially an impact on shallow gas aquifers. So that's a contemporary issue that we're facing. What about the next 20 to 50 years? What do we know about Alberta's water future, recognizing that we're facing both growing populations and growing demands for water? So we're potentially looking at variable supply of water with increasing demand. And so a project led by Dr. Greg Goss at the University of Alberta with collaborations at Calgary, University of Calgary, Lethbridge, Regina, Switzerland, and Integrated Sustainability are trying to bring together a better sort of future forecasting, both with future water supplies and future water demands and water use, to understand both the competing demands that are being made from different industries, different sectors, to come up with management scenarios and understand those management scenarios that provide for more optimal use of the water resources, and then to have an economic analysis underlaid on this so we can make tough decisions as water becomes a more priceable commodity in the future. So a number of complex results are coming from this work, and I'm just going to provide one very simple graph that's very illustrative, and I think it's one that we sometimes forget from a water supply, water demand, water use perspective in the province. So simple graph, two axes, across the x-axis indicated at the top, millions of cubic meters of water used per year by different sectors, color-coded for agriculture, municipal, oil and gas, and so on. And then on the y-axis, we've got indicated a number of different basins in the province, starting with the Oldman, the Bow, and the Athabasca. And I'm just going to highlight the Oldman, the Bow, and the Athabasca if we want to look for example. Certainly if you look at national and international media, you would think all of Alberta's water use problems are in fact in the north. They're all in the Athabasca, and we're running the Athabasca dry. And that, in fact, the Athabasca is maybe one of our smallest running rivers in the province. Looking at a graph like this, you'd think maybe the Oldman and the Bow are in fact our biggest rivers, because they demonstrate two examples of where we've got the biggest water use in the province. So what are some take-home messages? One, sometimes the popular messages that you find from a communication perspective maybe don't match what some of the water use challenges are in the province. And secondly, if you want to start talking about things like conservation, efficiency, and productivity, and we look in different basins, the sectors that we'll look at to try to enhance efficiency and productivity in the north of the province, in the Athabasca, where certainly the predominant use is related to oil sands mining, is very different from looking for solutions to relate to conservation efficiency and trying to maintain ecological base flow in rivers in the south like the Oldman and the Bow, where clearly irrigation and the benefits that we get from irrigation are the ones that are challenged with relating to our river systems. And then what about long-term water supply issues in the province? So here's just a picture of Dr. Dave Sauchin from the University of Regina, and we've got one of his collaborators sitting right in front of me here, Dr. Nessa Illich from the University of Lethbridge, working with EPCOR, the City of Calgary, trying to look at really long-term water issues to address, to increase our understanding of reliability of long-term water supply and to support development of management systems that can respond to an inherent variability in this water supply. So a picture here, we've got Dave Sauchin holding a cross-section from a tree that responds very well to both drought and wet years, a cross-section from a white bark pine growing in the foothills of the Rockies. And so what you can do with this cross-section is look at how fast the trees grow in any given year. And certainly for the last 80 to 100 years, we know what the climate was in Alberta, and you can relate the growth of that tree to known weekly, monthly, and yearly flows in either the North Saskatchewan, the South Saskatchewan, or the Athabasca River systems. And from that, build a model. And that model relates tree growth to river flows. And that what then happens is this tree actually provides a repository for climate that goes back, in this case, in many cases, back to 1100 AD. And so we've got now a model of river flow back to 1100 AD that tells us a little bit more about climate variability, so we can understand what we might be seeing in the future based on what we have seen in the past. So here's just a graph of water flows, modeled water flows, in this case the Athabasca River. It's very similar in the North Saskatchewan and the South Saskatchewan. 1100 AD to present on the x-axis, modeled yearly water flow on the y-axis. And we can see a dark line. The dark line is a 15-year running average. And I've circled something at the end. That's the amount of time that Alberta has been a province in that red circle there. So what can we say about a few things? One, we've had pretty average water flows in Alberta since we've become a province. We haven't seen the highs, we haven't seen the really wet years, nor have we seen some of the droughts that have been experienced in the past. So what are the take-home messages from this work? Number one, any assumption of a static water supply is grossly incorrect. In fact, we can expect possibly, in the absence of any sort of climate change, certainly from variability, both wetter and much drier time periods in the future, simply based on experience from the past. And from a municipal perspective, we have to think about risks to quantity and quality and develop mitigation strategies because we have a growing population dependent on these resources. So these are the kind of risks that sort of present themselves to Alberta. Alberta itself has no unique challenges that might impact our water resources. These challenges include an expanding economy, a growing population, increased energy development, increased expectations for environmental performance, further opportunities to add value to our agricultural resources with this growing recognition of both climate change and variability. So we can certainly look at these challenges. There's certainly opportunities for innovation that can address issues related to things like aquatic invasive species, to floods, to droughts, to eutrophication, to this challenge between resource development and food production and competing demands. So I just want to touch very briefly on what our current investment focus is as we move forward in our water innovation program. We're basically focusing our investments in four principal investment areas, what I'll call our water challenges, water opportunities, to continue to address issues about future water supply and understand aspects of watershed management, whether they're sort of broad-scale watershed management issues, issues related to groundwater storage, groundwater resources, issues related to storage, and we've certainly seen some announcements related to water storage projects in Alberta in the last day, and then issues related to resilience and the ability of our infrastructure, our economy, and our ecology to deal with both future floods and droughts. Aspects about healthy aquatic ecosystems in terms of continued innovation to support implementation of the wetland policy through wetland restoration, to deal with issues of non-point source pollution related to nutrient loading and contaminants in our lakes and rivers. We've seen great strides in Alberta dealing with aquatic invasive species in the last year, updates to regulation, updates to policy, and updates to a lot of efforts to deal with prevention, but we'll have to focus someday on rapid response and mitigation, and there's some innovation required there. And then certainly lastly to deal with the fact that you've got contaminated water in the form of oil sands processed water, and the role that either chemical, physical treatment, engineered wetlands, or pit lakes can be presented to deal with these issues. Conservation, efficiency, and productivity. We've seen great strides in a number of sectors. Our irrigation sector has certainly shown great significant advancements since the year 2005 in advancing their CEP in the province. There's future opportunities there related to enhancements for municipal water use and reuse, and we've heard a lot about SAGD water treatment already by Vicki Lightbound earlier this morning. And then lastly, with respect to water quality protection, further enhancements with respect to drinking water, wastewater treatment systems, industrial water use from oil sands and hydraulic fracturing operations, and then lastly, growing recognition and concern about pathogen and contaminant impacts on both urban and rural water supplies. So our investment principles are principles that are founded under the Alberta Water Research Innovation Strategy, that our portfolio needs to be relevant, it needs to be collaborative, the solutions are complex, we want to have high impact research program that's transparent and the results are shared, and we need to be adaptive. You've got to be careful what you pray for. Sometimes when you're not getting rain and you finally get it, you get too much. Got two announcements to finish off this, this presentation. We're certainly happy that we're able to talk about the fact that we have a 2015 call for proposals that's going to be opening very soon, and it's going to address, as we're going to open an opportunities for innovation ideas to come to us that will evaluate, manage, and fund in 4 broad priority areas that I just had an opportunity to provide a summary for you. And then lastly, I just want to present something that's coming up in 2016. In March 22nd, 23rd in Calgary here. This year we're partnering with COSIA, and there's the COSIA AI-EES Water Conference. It's going to be held at the BMO Center March 22nd, 23rd. I've got a website address here. You can go online. It's, we're receiving abstract submissions for presentations, and I've certainly an opportunity to see all kinds of innovation as it relates to water management issues and industrial development in northeastern Alberta will be presented there. So with that, I get to say thanks for the opportunity, and I get to invite our next speaker up on stage. So certainly thanks. And if you could join me when I okay, Eddie, I'll let you clap first. I'd like to welcome Bruce Beattie up to stage. He's the Director for Research and Development with EKS, Electrokinetic Solutions, a company that we've had an opportunity to work with through a couple different stages of technology development that's looking at some very innovative solutions to deal with fluid tailings and fluid tailings management in the province. So certainly, Bruce, welcome you up on stage here.